Just a quick video to explain why these two molecules of 1,2-dichloroethane are the same, but these two molecules of 1,2-dichloroethene are different. So to explain why these two are the same, we have to look at the nature of the carbon-carbon single bond. I'm only going to look at the orbitals that are involved in joining these two carbon atoms together by this covalent bond. So we've got an orbital here, which is actually an sp3 hybrid orbital. One of these electrons in the pair belong to this carbon, and we've got exactly the same going on for the left-hand carbon as well. This is what we call a sigma bond, and in sigma bonds it's the ends of the orbitals that overlap with each other. And because of this type of overlap, it kind of creates an axis by which the atoms can rotate. And so we have free rotation of these bonds. So I can very easily turn this molecule into the one on the left. And so because of the free rotation, these are the same. So again, if we look at the bond between the two carbon atoms, but this time it's a double bond, we'll start with the diagram as it is at the moment and just explain that each carbon in the carbon-carbon double bond uses 3 of its 4 outer electrons in sigma bonds. So we've got the actual orbital shown here with the electron pair in, and we've got the same going here and here and on this side too. The 4th electron, however, is in a p orbital. Now what's actually gone on to create these orbitals here is something known as sp2 hybridization that I cover in a separate video, so I'm not going to do that here. So we've got the 4th electron in this p orbital, and if you remember, the p orbital region of space expands above and below the sigma bond. Run out of space there. You get the idea. So it expands, and it'll expand to such an extent eventually that the orbitals overlap. So instead of having 2 separate p orbitals, we've actually got a new region of space. I'll tidy this up in a second, and the electron pair move around in this region of space here or down here. So I've tidied the diagram up now, so we've got this new region of space formed by the sideways overlap, not end to end now, but the sideways overlap of the p orbitals. So the pair of electrons can either live up here or down there. This type of covalent bond is called a pi bond, and essentially it locks these two carbon atoms in space, and so we can't, like we could before with the single bond, the carbon-carbon single bond, we can't rotate these two green atoms round, and so this is different to this one.